My dear students, now we are going to look at higher order decoder design. So we will take up a decoder. This decoder uh, having two input lines, four output lines, two input lines with active low enable and active low outputs. Okay. In the previous lecture, we have seen how 2 to 4 line decoder is going to work when active high inputs, active high outputs. Now in this case, enable is active low. This is enable bar. Inputs, let's say A and B. Outputs are Y0, Y1, Y2, Y3. We try to understand its operation, slightly different from what we have discussed earlier. Then we go for the design. So if you look at this, the inputs are enable bar A, B, outputs are Y0, Y1, Y2, Y3, right? So can I call this as a truth table? Because it is a input output relation. These are inputs and these are outputs, right? So once that is being done, let's try to see it. When enable is equals to 1, doesn't matter A and B, output is always ones. What is always ones is it is inactive. 1, 1, 1, 1. When this is 0, it is functioning. When this is 0 and 0, this is 0, rest all ones. When this is 0, it is functioning 0, 1. This is 1, this is 0, this is 1, 1. I am saying active low. Active low means when output is low, it is active. So when 0, 1, Y1 is low. When 0, 0, Y0 is low because active low output. 0, 1, 0. So it will be 1, 1, 0, 1. Next, if it is 0, 1, 1, 1, 1 is 3. Device is on. So what it will show? 1, 1, 1, 0. When 3 input is there, when 3 is the input, okay, active high because 1, 1, Y3 will be low. When 2 is the input, Y2 is low. When 1 is input, Y1 is low. When 0, 0 input, Y0 is low because active low outputs. Okay. As we have seen earlier, this enable helps us in order to expand the decoder, or we can have a higher order decoder. So what we try to do is, as an example, I want a 3 line to 8 line decoder from 2 line to 4 line decoders. So inputs are here 3, inputs are here 2. Okay. So what we try to do is, if you look at the outputs, 8, 4. So if you, I need 8 outputs, but from my decoder, given decoder, I have only 4. So if I have two such things, I can have 8 outputs. But there is incompatibility. Inputs are 2, inputs are 3. We will do something for that. Let's try to understand that. What exactly that we are doing. So I'll take one 2 to 4 line decoder. There will be 4 outputs. Another 2 to 4 line decoder. 2 to 4 line decoder. There will be 4 outputs. I call this as Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Okay. Once this is being done, I have two input lines and I have two input lines. If I take this two separately, what is going to happen? It will become 4. So there is no such thing. So we need to have a common two inputs for both the decoders, because from which we try to choose one out of the four. Let's say this is A, B. But if I go for 3 to 8 line decoder, how it look like? 3 inputs. Let's say A, B, C. What I got is A, B. I need to get C. So I represent C. This I am going to connect it to enable input of decoder 1 and decoder 2. So I will take this, then I will connect through an inverter to enable bar. There is a bubble here. This is enable bar. This is also a enable bar. Now when C is 0, this device is going to function. When C is 0, when C is 1, okay, here is a bubble, here is an inverter. So what is this? Active high. When C is equals to 1, this is going to work. Okay, when C is equal to 0, it is going to work. So on the whole, what I am going to get? So if you represent ABC, okay. So here, what exactly that I am trying to see is C. I am writing like, instead of writing like this, I am writing like this. What is that? Is C A B C, where I am taking C as MSB, A as LSB. In that case, this works. How is like this? If you write the table for say CBA 0000001 010 011, then 100 101 110 111. If you see these 4 cases and you see these 4 cases, when C is 0, what exactly that we are trying to do is, when C is 0, your device 1 will be working. Why? Because this is 0. When enable bar is 0, this works. What AB will do? AB will choose 1 out of the 4. When C is 1, when C is 1, 1's complement is 0. So here it is 0. 0 means 0 is enable bar. When this is going to function, this is decoder 2. This is going to function when enable bar equal to 0. So currently C is equals to 1. C is 1. When C is 1, C1, after the inverter it is 0 and enable bar is 0. So this will be on. Once again, AB is going to change. A is equal to B equal to 0, 0, 1, 1, 0, 1, 1. So this is going to choose 1 out of 4, which is maybe Y4, Y5, Y6 and Y7. Whereas this is going to choose Y0, Y1, Y2, Y3. So this is how, by connecting lower order decoders, I can get higher order decoders. So in this process, like we have seen in demultiplexers, multiplexers, okay, we are using enable pin to cascade them. Okay, this is available commercially as a IC form, as integrated circuit form. Okay, as a IC number as 74139. 74139. It is 2 line to 4 line decoder. Similarly, what we have designed here, okay, is 3 to 8 decoder. 3 to 8 decoder also available commercially as an IC as 74138. Okay. So now what I can do is I can use 74138 3 to 8 decoder. I can design 5 line to 32 line decoder. How I am able to say how 5 line to, this is n is to 2 power n. N is equals to 5. When n is equals to 5, what is 2 power 5 is 32. Let's say n is equals to 6. What is 2 power 6 is 64. So 6 line to 64 line. Similarly, when n is equal to 7, what is 7? 128. So 7 line to 128 line decoder. Okay, this all we can get it from say 3 to 8 or 2 to 4. Okay, if you want to get 3 to 8, say for example, I want 5 line to 32 line decoder. Let's we look at the calculation diagram, you can work it out. Okay, so what I try to do is I try to choose how many 3 to 8 decoders given are this. So if I look at the output lines, input lines we will work it out, of course, along with the enable inputs I will work it out. What is that working out is just is like this: 32 outputs, 8 outputs. So I need 4, right? To get 32 outputs from 8 outputs, I need 4. So I need 4 3 to 8 decoders to build 5 line to 32 line decoder. Okay. So here 3 lines are there, here 3 lines are there. How many lines extra we have is 2 lines extra. These 2 lines, what we try to do is we use 2 lines to choose 1 out of 4. Okay. So 3 lines are 5 lines, 2 lines. How many difference? 2 lines difference. These 2 lines to choose 1 out of 4, because we are using 4 3 to 8 decoders to get 5 lines to 32 line decoder. So what exactly that is? 3 lines are inputs, 2 lines are used along with the enables, so that I can construct 5 line to 32 line decoder. Okay.